Okay, assalamu alaikum everyone. Let's start. So there is one thing that is left that I want to quickly cover before we move on to circle equations. Okay, and that's about finding area of a kite or a rhombus. Let's say you have a kite like this. Okay, so just give me a minute. I'll just make this shape. All right, so let's say you have a kite that looks something like this. Let's call this A, B, C, D. How do you find the area of this kite? Now, one idea is that you break it down into two triangles and you say that the area of kite ABCD is equal to, let's break this kite down into two triangles like this. So the area could be equal to 2 times the area of one of these two triangles. All right, so you could say this area is equal to 2 into the area of the triangle ABC maybe. All right, so just find the area of one of these triangles, multiply that by 2, and that will give you the result. Okay, so that's something that you could do here. Now, how do you find the area of triangle ABC? If you use half into base into height, you could say if AC is the base, if this length is the base, then what would be the height? Height would be perpendicular like this. Remember, in a kite, you get a 90 degrees angle where the diagonals meet each other. So if we were to call this point X, the area of the triangle would be 2 into, so 2 is outside because we have two triangles like that. What about the triangle? What about the area of triangle ABC? That would be half into AC, which is the base of this triangle, multiplied by BX, which is the height of the triangle. All right, so we can just multiply these two lengths and divide that by 2. Now, how do you find BX? BX is actually half of BD, right? So BX is half of BD. Now, if you were to simplify this, you would see that 2 and 2, they get cancelled. And what are we left with? We have half into AC into BD. That turns out to be the area of the kite. Now, what is AC and what is BD? You see, AC and BD are the diagonals of this kite. All right. So from this, we actually get a formula that we could use directly for the area of a kite. And that would look like this. Area of a kite. Now, this formula also works for a rhombus because a rhombus is just a special kind of kite that has all sides equal. It's equal to half into D1 into D2. All right, so that's the formula that we have for the area of a kite or a rhombus, where D1 and D2 mean D1 and D2 are the diagonals of the kite. These are the lengths of the diagonals. So you'll have to do this quite often, that you'll have to find the area of a kite or a rhombus. What do you do for that? You just use this formula. This is one possibility. If you want to memorize this, you can just use this directly, input values, you get the area of the kite or the rhombus. All right. Or of course, the other idea is that you break it down into triangles, and that will give you the same thing as well. This formula also comes from that same idea that you're adding the areas of those two triangles. That's where this formula is coming from. You could remember this formula and just use it directly if you want, or break it down in triangles and then find the area using that. So that's your choice. All right, so this is what I wanted to mention as well before we move on. So keep this in mind. If you wanted to find the area of a kite or a rhombus, you could use this formula for that. Let's move on to equation of a circle. All right, so that's the next thing that we want to do in this particular session. How do you find equation of a circle? Let's think about this. Now, first of all, remember, what does equation of anything mean? So for example, if we have a straight line that looks like this, let's say this has an equation y equals 2x plus 5. What exactly does this equation mean? How is this equation connected to this line? Basically, every point on this line satisfies this particular equation, right? Every point in this line satisfies this particular equation. For example, if I knew that the x coordinate at one point here was 1, what about the y coordinate? The y coordinate would have to be 7 so that it satisfies this equation. Similarly, if there was another point here which was -2, then the y coordinate corresponding to that would have to be 1. All right, because when we input -2 into this, we get the corresponding value 1. So every point that lies on this line, it has to satisfy this particular equation. And if you think about it the other way around, this equation represents every point on this line. Every point on this line is represented by this equation. Okay, that's what it means to have the equation of any graph. So for a straight line, this is what it means. Now, what about the equation of a circle? Now, when we talk about the equation of a circle, let me actually start with an example first of all. Let's say we have a circle that looks like this. So we have this circle. All right. And let me actually make it slightly bigger. All right. So this is a circle that I have. Now, let's say we have these x and y coordinates, x and y axes, through which this circle is passing. All right, so this is how the circle looks like. We have the y-axis here, and we have the x-axis here. All right. Now, equation of a circle represents equation of a circle has to represent every point on the circumference of the circle. All right, so that's how we define equation of a circle, that it should represent every point on the circumference of the circle, not every point inside the circle. The equation will only represent every point on the circumference of the circle. All right. Now, how do we write down an equation of the circle, let's say, that has a center at the origin? And let's say we know the radius of the circle as well. Let's say the radius of the circle is 5. So we know that the radius is 5. We know that. Okay. Now, how can you write down an equation for this? Since the equation has to represent every point on the circumference, let's take a general point on the circumference. Let's say that point is here. This is point xy, let's say. So you need some kind of relation between x and y, some equation that connects x and y such that it would represent every point on the circle. Now, how can we think about this? If you make a triangle here that looks something like this, such that you have a 90 degrees here, what would be the base of this triangle. You see, the x coordinate of this point is x, so the base of the triangle is therefore going to be x. What about the y coordinate? The y coordinate is y, so this vertical length, this is going to be y. Now, how can you connect x and y with each other? You can say x square plus y square equals 5 squared. So for now, let's actually make a general, let's say that this radius was r. So for now, let's make it general. Let's say the radius was r. You can connect x, y, and r using this equation, using simple Pythagoras. Base square plus perpendicular square should equal hypotenuse square. So x square plus y square should be equal to r square. So this is an equation that connects x, y, and r. Now, if you know that the radius of the circle, if r equals, let's say 5, you can write down the equation of the circle like this. You would say if r equals 5, then this becomes x squared plus y squared equals 5 squared, and the equation would turn out to be x squared plus y squared equals 25. So for this particular circle, a circle that has its center at the origin, the equation of the circle is given by x squared plus y squared equals 25. All right, so this is the equation of this particular circle that has its center at the origin and its radius is 5. This is how x and y are going to be connected. So every point on the circumference here is going to satisfy this particular equation. All right, so that's how you can find equation of a circle with center at the origin. Now, what if the center was not at the origin? Let's say it was somewhere else. Okay, let's say the center was somewhere else. Now, how do we think about that? Let me take another example. Now, let's say we again have x and y axes like this. All right, and there's a circle somewhere around here like this. The circle like this. Okay, and we want to find the equation of this circle. Now, its center is not at the origin. The center of the circle is not at the origin. Now, how do we think about this? We have the x-axis here and the y-axis here. Now, let's say this is a circle that has its center here. Let's say this is the center. And the center has coordinates. The coordinates of the center are, let's say, A and B. Let's call the center C. Its coordinates are A and B. Okay, so this is the center of the circle. It has coordinates A and B. And the radius of the circle is, let's say, represented by the letter R. Now, how can we write down an equation for the circle such that the equation would represent every point on the circumference of the circle? How can we write down such an equation that represents every point on the circumference of the circle? Now, let's think about this. The coordinates of the center are A and B. So if I were to write this here, so this is point C. The x coordinate of C is going to be A. The y coordinate of C is going to be B. So this point is B and this point is A here. Okay. Now, let's take a general point on the circumference just like before. So let's say I take any point on the circumference. Let's call that x and y. So let's say we have a point here. Let's call this point x, y. All right. And that's a general point on the circumference of the circle. Now, how can we connect x and y? How can we connect x and y with each other? Now, remember, the radius is represented by the letter R. So this is the radius of the circle. Now, if this is the radius of the circle, we could try and make a triangle that looks like this. Just like before, we make a right angle triangle, and this right angle triangle looks like this, such that the 90 degrees is right here. Okay. Now, what about the length of this triangle? If we're calling this point xy, it's a general point on the circle, on the circumference of the circle. If we're calling this point xy, that would mean this x coordinate here is x, all right? And the y coordinate here is y. What about these lengths now? Think of this base. What's the length of this base? It's going to be x minus a, right? So that's the length of this base here. That's x minus a. What about this vertical length? What about the length of this vertical side? It's going to be y minus b. So this vertical length here is y minus b. Now, how can we connect these three sides? Again, it's a right angle triangle. We could use Pythagoras again. We could say base squared plus perpendicular squared should equal hypotenuse squared. All right. So we could write this like this. We could say this is we could connect x, y, and r like this. X minus a whole squared plus y minus b whole squared. So that's base square plus perpendicular squared equals hypotenuse squared. What's the hypotenuse? Hypotenuse is r, so that's going to be r squared. And this is what the equation of a circle looks like. So the standard form for the equation of a circle is this. It's x minus a whole squared plus y minus b whole squared equals r squared, such that a and b are the coordinates of the center of the circle and r is the radius of the circle. So if you have the value for r, you can just input that here. If you have the coordinates of the center, you can input those coordinates here, and you would get the equation of that circle. All right. And what does this equation represent? This equation represents every point on the circumference of the circle. So this is the standard form for the equation of a circle now. Keep that in mind. This is the standard form that we have. In this form, the coordinates of the center are a and b, and the radius is given by r. Radius is represented by the letter r. Okay, so that's the standard form of the equation of a circle. What exactly does this represent? This equation represents every point on the circumference of the circle. All right, it does not represent points inside the circle. It only represents points on the circumference of the circle. All right, so that's how we write equation of a circle. All right, so keep this in mind. This is the standard form that you have now. And keep in mind that a and b are the coordinates of the center of the circle, and r is the radius of the circle. Now, let's try and use this. Let's say we want to find the equation of a circle. Now, let's do some examples of this. So we want to find the equation of a circle that has radius 3 units, and its center at, let's say, -2 and 7. All right, so we need to write down the equation of the circle. Now, you have to remember the standard form for the equation of the circle, right? Just like we had standard forms from straight line for straight lines, y equals mx plus c. That was one possible form. Another form was y minus y1 equals m into x minus x1. Just like you remember those forms, you also have to remember the standard form for the equation of a circle. What does it look like? It's x minus a whole squared plus y minus b whole squared equals r squared. That's the standard form for the equation of a circle. It's not a formula that's given in the formula sheet. It's not given in the formula sheet. It's the standard form for the equation of a circle. You have to memorize this. Okay? All right. So that's the standard form. Now, all you have to do is just input values here. 3 is r. That's the radius. Okay? And these are the coordinates of the center A and B. All you have to do is just input values here so that it becomes x minus a. A is -2, so you could write this as x minus -2 whole squared plus y minus b, so that's y minus 7 whole squared equals 3 squared. And if you simplify this, it becomes x plus 2 whole squared plus y minus 7 whole squared equals 9. That is the equation of the circle. This is one way to write down the equation. You could also just expand it and write it in expanded form. In that case, it would become x squared plus 4x plus 4 plus y squared minus 14y plus 49 equals, or let's actually take it here, bring it here to the left, equals 0. Now, you could write this as x squared plus y squared plus 4 times x minus 14 times y plus 44 equals 0. And this is another way of writing down the same equation. And that's also fine. All right. 44 is coming from 49 plus 4. That's 53. 53 minus 9 is 44. All right. So this is the form that you need to remember. If they want an expanded form as in the answer, you could just expand that. And this is what you get from that. All right. So that's how you write down the equation of a circle. Remember this form, x minus a whole squared plus y minus b whole squared equals r squared. You just have to input values there. All right. Now, let's take another example. Sometimes what you have to do is you have to do the other way around. So you might have the equation of the circle given, and you might be asked to find the radius of that circle and maybe the center of that circle. So let's say we have something like this, that we want to find the center and radius of a circle with equation x minus 5 whole squared plus y plus 2 whole squared equals 40, let's say. So we have this equation of a circle. It's given like this. Now we need to find the center of the circle and also the radius of the circle. These are two things that we're looking for. Now remember what the standard form looks like. The standard form is like this: x minus a whole squared plus y minus b whole squared equals r squared. Now you just compare these two and you figure out. From here we get a equal to 5, right? So one way to remember this is you just flip these signs in the middle, because we have negative signs here. When we multiply this number by minus, it's going to change the sign. All right, so a equals 5. In this case, This is plus 2, it becomes minus 2. So b equals minus 2. All right, because when we equate minus b to plus 2, the value of b turns out to be minus 2. Okay, so b is minus 2 here. What about the radius? R square equals 40. So the radius is going to be square root of 40. Remember, radius cannot be negative. So you are only going to consider the positive value here. Okay, so what are the coordinates of the center then? You can write them down here like this. You can say the center is at 5 and minus 2. And the radius of the circle is square root of 40. You could leave it like this in square root form or write this answer in decimals. It depends on the question. You could leave it in both forms. All right. Okay, let's move on. Now, there's another thing that you might have to do here, and that would be that you might be given the expanded form sometimes. Let's say they again ask you to find the center and radius of a circle, but now the equation looks like this. So let's say the equation is x squared plus y squared minus 14x plus 10y plus 10 equals 0. This is the equation of the circle now. Now, we need to find the coordinates of the center and also the radius. These are two things that we're looking for. Okay. Now, how do we figure those two things out? Remember the standard form of the equation of a circle. What does that look like? It's x minus a whole squared plus y minus b whole squared equals r squared. Now, this is not that form. This is expanded form. We looked at this earlier, how to go from this standard form to the expanded form. We just expand these using identities. How do you go the other way around? Remember this, we've done this in quadratics. How do you go from expanded form to something like this where you have perfect squares? In order to go the other way around, you actually have to complete the square. And that's what we do here. We complete the square for x and y separately here. And once we complete the square, we can just compare with the standard form to find the center's coordinates and also the radius. Now, how is that going to work? Let's try and figure this out. First of all, the first thing you're going to do is you're going to write all the x terms together. So you have x squared minus 14x. Write these two terms together. Now leave some space because we want to complete the square for this. Write the y terms together. So you have y squared plus 10y. Again, leave some space. Take the constant to the other side. You don't need that here. That's minus 10 on the other side. All right, so write x terms together and y terms together. Now you have to complete the square for each one of them separately. Okay, now what do you do for this? Divide 14 by 2. That gives you 7. You add 7 squared here and also subtract 7 squared. Similarly, we have 10 here. Divide 10 by 2. That gives you 5. You add 5 squared here and also subtract 5 squared here. Now, these three terms give you a perfect square. These three terms also give you a perfect square. You take x from here, minus from here, 7 from here, and you take y from here, plus from here, and 5 from here. All right. And that gives you x minus 7 whole squared. This is outside the square. So this is minus 49 plus y plus 5 whole squared. That's the second square that you're getting from this. And then minus 25. On the other side, you have minus 10. Now remember, when you're completing the square here, for the equation of a circle, the coefficients of x squared and y squared, they're always going to be 1. All right? They're always going to be 1. or at least they're always going to be equal to each other. So if they're not one, you can just divide the whole equation by that number and they will become one. All right, so completing square process here is not going to be that difficult. You won't have to take anything common here. You can just complete the square as it is. So it's just going to be one single step. Okay, and that's going to be pretty quick. The coefficients of x squared and y squared here cannot be different for the equation of a circle. If they were different, it would not be a circle anymore. It would become an ellipse like this, or maybe like this. Okay, so the coefficients have to be equal. They're generally going to be both one. If they were not both one or not both equal, you would not get a circle, you would get an ellipse like this. And that's not part of your syllabus. That's not going to come. So what do we do now? Once you've converted to the completed square form, all you have to do is just take the constants to the other side. And that's going to give you x minus 7 whole squared plus y plus 5 whole squared on the left side. Take 25 and 49 to the other side and subtract from that 10. So that's 74 minus 10. That gives you 64 on the other side. Now you compare with the standard form. The standard form is x minus a whole squared plus y minus b whole squared. That equals r squared. I can just compare them. In place of a, you have 7. In place of b, you have minus 5. And in place of r, you have square root of 64. So you can write down the center's coordinates. The center's coordinates are 7 and minus 5. And the radius, in this case, turns out to be square root of 64. And these are two things that we were looking for. We had the center's coordinates and the radius. That's all that we wanted. All right, so if you have an equation given in expanded form like this, what you first have to do is you have to first complete the square by writing x terms together and y terms together, complete the square for both of them individually, convert it to standard form, and then just compare to find the center's coordinates and the radius of the circle. All right, so that's all that you need to know about equations of circles. Now, of course, the questions that you get in this are going to be slightly tricky. So we'll be doing some practice questions. But before that, let me remind you of something that you also need to know for this topic. So there is something that you did in O levels that is going to be required here as well. And that is circle properties. Remember that? Circle theorems, circle properties. That is going to be required here as well. Angle property of circle. Okay. Now, let me quickly remind you about some of them because they are going to be important here. You will be using them here and also in the next topic, which is circle. Not the next topic, but whenever we do that circular measure, you also need these properties for that topic, but they're going to be very important in this particular topic at least. So let's quickly review some of these properties that you need to know about. All right. Now, first of all, let's start with this one. Angles in the same segment are equal. Remember this property? So if you have a chord, let's say this is the chord, or you could also think of this arc. If you were to make lines from the endpoints of this chord or arc to the circumference of the circle, whatever angle they make on the circumference, they're going to be equal. So this angle is equal to this angle. These two angles are equal to each other. So if this angle was x, the other would also be x. All right, so you've done this property in O level. You have to remember this. Angle made by a chord or an arc in the same segment, they are equal. So if I were to make another line here like this would also be equal. Okay, so if I were to make a line like this here and like this here, this angle here would also be x. So I could make any, I could have any third point on the circumference, the angle there would be the same. Okay, so that's one property. Let's move on. Now the next one is the angle in a semicircle is always 90. So think of it like this, angle made by a diameter AB is the diameter here. Angle made by a diameter on the circumference, this is always 90. All right. So if you were to join the endpoints of the diameter, if you were to make lines from the endpoints of a diameter to a third point on the circumference, the angle here is going to be 90 degrees. You could make any other angle that would also be 90. For example, if I had this angle here, I had another line going like this, maybe here, and then here like this angle is also going to be 90. So any angle that you make here is going to be 90 like this on the circumference. It's also true the other way around. Any chord other than the diameter is also a chord, right? But any chord other than the diameter cannot make a 90 with any point on the circumference. So if a chord is making a 90 degrees on the circumference, it has to be the diameter. No other chord can make 90 degrees. All right, so that's an important point to remember. Only diameter can make a 90 degrees on the circumference of the circle. No other chord can do that. And also, if you were to have another angle inside the circumference like this, inside the circle, let's call this angle alpha. Alpha is going to be greater than 90 degrees. So if the diameter is making an angle inside the circle, if the endpoints of the diameter are making an angle inside the circle, this is going to be greater than 90 degrees. And if you had a point outside the circle, maybe like this, the angle made here outside the circle is going to be less than 90 degrees. It's going to be equal to 90 only at the circumference. Only this angle is going to be equal to 90. All right, so the angle theta here is equal to 90 degrees. The other angles, they're either greater than 90 if the point is inside the circle, or less than 90 if the point is outside the circle. All right, so this is a very important property. It's used a lot. You have to know this. Let's move on. And the next one is that a line drawn from the center of a circle to the midpoint of a chord is perpendicular to the chord at 90 degrees. What that means is, if you have the center of the circle here, this is the center. If you were to draw a line from the center of the circle to the midpoint of a chord, so this line here is a chord. If you were to join the midpoint of this chord to the center of the circle, the angle that you get here is going to be a 90 degrees. And that's true for any chord in the circle. So if I have a chord here like this, and if I were to join the midpoint with the center like this, the angle that I get here is going to be 90 degrees. Okay, the angle is always 90. And it's also true the other way around. If the angle that the center is making at a point on a chord is equal to 90 degrees, if this angle is 90, then this point has to be the midpoint. All right, it can't be any other point. It's also true the other way around. If you know that the angle is 90, then that point has to be the midpoint. All right, so that's another important property that you need to know about. Let's move on. Angle at center is twice the angle at the circumference. So again, if you think of a chord like this, or maybe an arc like this chord or arc, the endpoints of this chord, if they are making one angle at the circumference, let's call that x, the angle at the center is going to be 2 times that. All right, the angle at the center is going to be 2 times that. Okay, you have to keep this in mind. Let's move on. This is another one. Tangents from a common point to a circle are always equal. So for instance, if you have a point A here, and If I were to make two tangents from the point A, one on this side, touching the circle at C, the other on the other side, touching the circle at point B, these two tangents are going to be equal to each other. So AB is going to be equal to AC. Okay, now it looks like this angle is 90, but that's not always true. So let's take this other example where we have this point P. From P, we are making two tangents, one touching the circle at point Q and the other touching the circle at point R. Again, these two tangents are going to be equal to each other. PQ is equal to PR. All right. Now, this is one thing. There are also some other things that are related to this particular property, and they look like this. If you were to join, and this is something that you would almost always do whenever you have a figure like this, where you have two tangents coming from outside the circle, what you're going to do is you're actually going to connect these points where the tangents are made to the center of the circle like this. Okay, and that will help you in some calculation somewhere. This figure that you get here, OQPR, this is a kite. Okay, this figure here, let's call this ORPQ. This is a kite. All right, this figure that you make, that you get here, that's a kite, and this angle is 90. Remember, the radius and tangent, they make a 90 degrees with each other, so these angles are 90. All right, and remember, since it's a kite, if you were to join P and O like this, they would divide the kite into two equal halves such that the line PO is the line of reflection of these 2 points, and basically everything on in the kite on either side. So this is a line of reflection of this kite, PO. What that means is this angle, if this angle is X, this angle would also be X. And if this angle is Y, this angle here would also be Y. These lengths are also equal because they're both radius, and the other two lengths are also equal. So it makes a kite, and in a kite, this diagonal is a line of reflection, OP. This is a line of reflection. So the angles are bisected and the sides are equal like this. Okay, so this is another important property that you need to know about. Tangents coming from outside the circle, they're always equal. And you also need to know about these properties, that that the shape becomes a kite. All right, and this is how the angles are related. Let's move on. Then you have the cyclic quadrilateral. What's a cyclic quadrilateral? In a cyclic quadrilateral, all the vertices of that shape lie on the circumference of the circle. They lie on the circumference of the circle. In a cyclic quadrilateral that looks like this, the sum of opposite angles is always 180 degrees. All right, so angle A and C, if you were to add them up, the sum is going to be 180, and angles B and D, if you were to add these two angles up, the sum would be equal to 180 for that as well. All right, so the opposite angles are supplementary, their sum is 180 in a cyclic quadrilateral. All right, and then finally, tangent and radius, they are always perpendicular to each other. So if at a point you have the radius and also the tangent, then they make a 90 degrees with each other. All right, we also talked about this earlier. Now, there are some properties here which are used more often than not. Now, angles in the same segment, it's not used that often in A levels here, but there are some which are used quite a lot. For example, angle made by diameter. This is extremely important. You'll see this over and over again. 90 degrees with the midpoint of the chord. This is another important property. Again, you'll see this over and over again. This angle at center being twice the angle at the circumference, it's not that important. You won't see this very often, but then this is very important. Tangents coming from a single point outside the circle, this is important. Cyclic quadrilateral is not that important, but the last one is the tangent and radius are perpendicular to each other. So there are 4 of these properties which are kind of more important than others. Midpoint of chord makes a 90 degrees with the center. Angle made by diameter is 90 degrees. Tangents coming from outside the circle are equal. They make the kite shape as well. And the radius is perpendicular to the tangent. So these are 4 more important properties that you have to know about. Okay. Now from the second property that we did here, I'm not sure about the exact number, but this property that we did here, where if you cut a chord at the midpoint, it makes a 90 degrees with the center. It also gives us something very interesting that we will actually use later to find equations of circle. And that is, since the line coming from the center of the circle cuts the chord at the midpoint when it makes a 90 degrees, we can say MC is the perpendicular bisector of that chord, right? So the perpendicular bisector of that chord passes through the center of the circle. Perpendicular bisector of the chord, it passes through the center of the circle. That's an important property. All right. So I've written this here. Center of a circle lies on the perpendicular bisector of every chord in the circle. Okay. Or you also think of it another way, you could say the perpendicular bisector of every chord in the circle, the perpendicular bisector of every chord in the circle passes through the center of the circle. This is a general property that you have for a circle. If you have any chord, if you were to draw a perpendicular bisector of that, it would always pass through the center of the circle. And that comes from this property that we did here, because the line coming from the center, if it cuts the chord at the midpoint, it makes a 90 degrees. So that means the perpendicular bisector of this chord has to pass through the center. Okay, so that's an important property. This is something that you have to keep in mind as well. All right. So these are some circle properties that you need to know about. You will need them when we do some questions. Now, let's move on and do another concept, which is actually related to what we've just done. And then in the next class, we will be doing some practice questions of this. Let me write that down here. So it's basically about finding equation of a circle using points on the circumference. Finding equation of a circle using 3 points on its circumference. Now remember this property that we just did. We said the perpendicular bisector of every chord in the circle, in a circle, passes through the center of the circle. Okay, this is an extremely important property. Now let's say we need to find the equation of a circle. So keep this in mind, keep this property in mind. Let's say we need to find the equation of a circle that passes through the points A, B, and C such that the coordinates are like this, for instance. So their coordinates are maybe you have a point A, it has coordinates -1 and 0. You have another point, let's say B, it has coordinates 2 and 1. You have another point C, it has coordinates 7 and -4. You have 3 points on the circumference of a circle. All right. And you want to find the equation of the circle. Now, how do you figure this out? Let me draw the circle here like this. So this is what the circle might look like. What you know is 3 points on the circumference of the circle. So one point is A, you have B and C. You could mark them here. Let's say point A is somewhere here. So it's 0, 1, and then -4. Let's say it's here. Point A is here, let's say. Then there's a point B. It has X coordinate to the right and Y coordinate is slightly above there. So it might be, let's say, somewhere, or maybe A is somewhere here, let's say. This is A, then B might be here. And you have another point C. It has a negative Y coordinate. It might be somewhere on the other side, maybe. Let's say that is around here. Okay. So I've just marked these 3 points. Now it doesn't matter where exactly you mark these, as long as you just mark them somewhere on the circle. Okay, on the circumference of the circle. So you have these 3 points. We need to find the equation of the circle. Now remember, what do we need for the equation of a circle? We need 2 things. What's the standard form? The standard form is x minus a whole squared plus y minus b whole squared equals r squared. We need 2 things. To write down the equation of a circle, we need the center of the circle and the radius of the circle. If we have these 2 things, we can write down the equation. Right? For a straight line, for instance, you needed a point and gradient. For a circle, you need the center of the circle and the radius of the circle. If you have these 2 things, you can write down the equation. Now, let's try this in this particular case. So which 2 things are we looking for? We're looking for the center of the circle and we're looking for the radius of the circle. Now, think about it. If we can somehow find the center of the circle, that might be somewhere here. If we can somehow find the center of the circle, finding radius after that is pretty straightforward because radius would just be the distance of O from B or from A or from C. That's easy after that. We can just find the radius using the distance formula. The only problem is, how do you find the center? Because once you found the center, the rest will be easy. Okay. Now, remember this property that we just discussed. The perpendicular bisector of every chord in a circle, it passes through the center of the circle. So we have 3 points on the circumference. What we can do is, we can say, let's have a chord like this, AB. Let's have a chord like this, BC. Both of these chords, if we were to draw perpendicular bisectors of these chords, one would go like this, and the other would go like this. They are both going to pass through the center of the circle. They are both going to pass through the center of the circle. All right. So if we can find the perpendicular bisectors of these chords, solve them simultaneously. Since they're going to intersect at the center of the circle, we can find the center's coordinates by solving them simultaneously. All right. So let me just draw that here again. We have one chord. So you can actually make it slightly neater. We could take any two chords, right? So we have three possible chords here. We have chord AB, we have chord AC, we also have chord BC. All we have to do is take any two of these chords, and find their perpendicular bisectors. So let's say we have one chord AB, we take this. We have another chord, which is BC. All right. Now, perpendicular bisector of BC is going to pass through the center of the circle. And perpendicular bisector of AB is also going to pass through the center of the circle. So these perpendicular bisectors are both going to pass through the center of the circle like this. Okay, so their point of intersection is the center of the circle. All we have to do now is find their equations and then solve them simultaneously. That will give us their point of intersection, and that point of intersection would be the center of the circle. All right, so that's all that we have to do now. Let's do that. So one thing that we're looking for is the perpendicular bisector of AB, and we're looking for the perpendicular bisector of BC. These two things are what we're looking for. Now let me write down their coordinates here. A is -1, 0, B is 2 and 1, and C is 7 and -4. Now, how do you find equations of perpendicular bisectors? You need the gradient of the original line. Let's find the gradient of AB first of all. What would that be? 1 minus 0 divided by 2 plus 1, which turns out to be 1/3. That's the gradient of the line AB. What about the gradient of the perpendicular bisector? That would be negative reciprocal of this. That turns out to be -3. Now, what about the midpoint of AB? Let's call this point M, let's say. Let's call the midpoint of BCN. Let's find the coordinates of M first of all. M is going to be -1 plus 2 over 2, y1 plus y2 over 2, that's 0 plus 1 over 2. And this turns out to be 1/2 and 1/2. So the coordinates of M therefore are 1/2 and 1/2. Do the same thing for the other perpendicular bisector. Find the gradient of the line BC first of all. Y2 minus y1, that's going to be 1 minus -4, that's 1 plus 4 divided by 2 minus 7. And that gives me so 5 over -5. Right, so this gives me 5 over -5, which is -1. Now, what about the gradient of the perpendicular bisector of this? That would be negative reciprocal of -1. Change the sign, take reciprocal. That turns out to be 1. Let's find the midpoint. Let's call this point N. What's the midpoint of B and C? X1 plus Y1, X plus X1 plus X2 over 2. That's going to be 2 plus 7 over 2. Y1 plus Y2 over 2, 1 minus 4 over 2. And these are the coordinates of the point N, 9 over 2 and -3 over 2. We can write down the equations now. We have a point and the gradient. What's the equation of this perpendicular bisector? Y minus 1/2 equals -3 into X minus 1/2. That's the first equation. So I'm using this -3 here and this point here. And for the other one, I'm using this 1 and this point here. This is what we're using to write down the equations. The second equation is going to be y minus 3 over 2. That becomes y plus 3 over 2 equals m, which is 1 into x minus 9 over 2. Let's simplify these equations. The first one gives us y minus 1 over 2 equals minus 3x plus 3 over 2. When 1 over 2 goes to the other side, it becomes minus 3x plus 4 over 2, which is 2. The other equation is y equals x minus 9 over 2 plus minus 9 over 2 minus 3 over 2. That's going to be minus 12 over 2, which is minus 6, x minus 6. This is the other equation. All right. Now, the center of the circle, that's right here, is the point of intersection of these two perpendicular bisectors. All right. So any two perpendicular bisectors that you have for the chords, their point of intersection is going to be at the center of the circle. All right. We just have to solve these two simultaneously here. Equate both of them. That gives us minus 3x plus 2 equals x minus 6. And we have minus 4x equals minus 8. And x equals 2 from this. Put this back in any one of those two equations. Y equals minus 3 into 2 plus 2. And that gives us y equals minus 4. The center's coordinates, therefore, are, it's called the center O. We called this O earlier. The center's coordinates are 2 and minus 4, and that's what we were looking for. All right, these are the coordinates of the center of the circle. Once we have the center, we can take any one of these points, A, B, C, find the distance of the center from that point. So radius could be OA, OB, OC. You could try any one of those three. Now, what was the point A? Let me write that here on the side. A point was 0 and minus 1, I think. Yeah, no, minus 1, 0, the other way around. Point A is minus 1 and 0. Let's use the distance formula to find the radius. OA, that's going to be x2 minus x1 whole square. So that's 2 minus minus 1. That's 2 plus 1 whole squared. Plus minus 4 minus 0 whole squared. And that gives us 3 square plus 4 square, which is 25. Square root of that turns out to be 5. So the radius is equal to 5. Now we can write down the equation of the circle. X minus a whole squared plus y minus b whole squared equals r squared. Just input values. This is a, this is b, and this is r. Equation of the circle turns out to be x minus 2 whole squared plus y plus 4 whole squared equals r squared, which is 5 squared, which is going to be 25. This is what the equation of the circle is. That is what we were looking for. All right. So this is how we find equation of a circle using 3 points on its circumference. All right. Now let me actually just copy a statement from somewhere here. Just find that. P1. Yeah, it should be, no, it's not here. P1 checklist. Here, equation of circle. Yeah. If I were to just copy this. So these are the steps that you have to follow. You can note them down if you want. To find the equation of a circle given points on the circumference. So if you have something like this, in which you have a few points, Unfair that time I don't need it. Let's actually just get rid of this. Yeah, let's take this example. So it's the same points. I just call them PQR here. In the above example, I call them ABC. It doesn't really matter. So if you have to find the equation of a circle that passes through the points P, Q, and R, how do you find this equation? Find the equations of perpendicular bisectors of any two of those three chords, PQ, QR, or PR. Find perpendicular bisectors of any two of these three chords. Solve them simultaneously. That's going to give you the coordinates of the center. Then find the distance of that center from any one of those 2 points. That is going to give you the radius. Then write down the equation of the circle. All of this is using this property here, that the perpendicular bisector of every chord in a circle, it passes through the center of the circle. So the perpendicular bisectors, they intersect at the center of the circle. All right, so that's another way of thinking about this. Perpendicular bisector of every chord in a circle, you can also think of it this way. It intersects, they intersect each other at the center of the circle. All right. So that's all that you need to know about equations of circles. That's all that you have in terms of concepts. Now, in the next session, we will be doing some practice questions in this, and then we wrap this topic up. And we will move on to functions after that, inshallah. All right. So I hope that was helpful. I'll see you again tomorrow in the next session. Take care. Allah Hafiz.